Students, we are going through the different techniques of multiplexing. और हम लोगों ने frequency division multiplexing और wavelength division multiplexing को cover किया था. Students, the third and the last multiplexing technique that we have is the time division multiplexing or TDM. Students, unlike FDM and WDM, your TDM is inherently a digital multiplexing technique. Students, once again, in this process, it's a digital process that allows several connections to share the bandwidth of a high capacity link, a link which has got a high bandwidth. Students, the difference is that instead of the different frequencies, that I divide this high capacity link into multiple channels. In this particular case, the different channels, the different connections, they time share this high bandwidth link. Students, as you can see on the slide, it's a digital technique. Now, before I go on to this discussion, I need to clarify that although this is a digital technique, that does not essentially mean that we cannot use this with analog signal. So if we want to send analog signals, we need to convert the analog signals into digital signals by using the process of sampling that we have already discussed. And once we have got the digital signals available, you can still use TDM to transmit those signals. And that happens in real life as well. So students, what you see on the slide is that we have got 4 different data streams. In this particular case, they are sharing one high bandwidth channel, and they use this digital multiplexing technique, the time division multiplexing, in which the digital data from different sources, they are combined to one time shared link. So first, you do a 1, 2, 3, 4, the data from each one of these connections. The second set is there from the second set of source, and then with every clock tick, the new set of data, it flows onto this high bandwidth link. Low rate channels on the left hand side multiplexed into the high rate link. Students, there are 2 basic types of time division multiplexing. The first one is called synchronous TDM, and the second one is called statistical TDM. Students, let's go into the discussion of each one of these in further detail. Students, first of all, in the case of synchronous TDM, you need to understand that in this type, each input connection has an allotment in the output, even if it's not sending data. So, in this particular case, you have got 3 inputs, and data is taken from every line every t seconds. For every clock tick, we are taking data from every single line. So you essentially come up with frames. In the first frame, you'll have A1, B1, and C1. As I told you, with every clock tick, we are taking data from each one of these 3 lines. Frame 1, frame 2, frame 3. And for every single input connection, we have got an allotment in every frame. So A1 or the line A will have a space in every single frame, even if A1 is not sending data. For example, if after A1, A2, and A3, line 1 or connection 1 has got nothing to send on this high bandwidth line, even then this particular first slot will remain empty if line 1 has got nothing to send, and will just send the data from line 2 and line 3s. Students, down here, each frame it consists of 3 time slots, as you can see, and therefore the duration of each time slot is T by 3. Students, in synchronous TDM, as we have discussed, the round of data units from each input is collected into this frame, and the data rate of the output link, it must be n times the data rate of the connection to guarantee the flow of data. Students, हम लोगों ने देखा कि in this particular case, the data rate of the link is 3 times the data rate of the connection. Every frame it consists of 3 time slots, and therefore the data rate of the link is 3 times the data rate of each of the individual connections. Students, it's important to summarize this concept. Synchronous TDM, in this case, every single line, every single connection will hold its slot on the actual link in the form of frames, and the data rate of the link is n times faster and the unit duration is n times shorter.